Hello, I'm David Valdés, and today I want to talk to you about exponential applications. And in particular, let's talk about growth and decay models. You've probably heard people say that's growing exponentially, referring to maybe population or bacteria growth or something like that. Hopefully your bank account is growing exponentially, but probably not, unfortunately. So let's take a look at a couple examples of growth and decay. So here are the official forms. Y equals a times b to the x, where a is some non-zero number and b is greater than 1, would give us some kind of growth. And over here, if a is non-zero and b is a fraction, then we'll get some kind of decay. So let's take a look at that through examples. Let me just put a growth example up here, so I'll try to make it look like that. How about y is equal to, let's try 2 times 3 to the x and see what that looks like. Let's make a little table. Okay, and let's start with, I'll just put 0 and a few other positive numbers. 1, 2, 3, 4, let's go up to 5. And 5, and see what all these guys look like in the end. Okay, let's plug in those values. At 0, y equals 2 times 3 to the 0 power. Anything to the 0 power is 1, so this just comes out as 2. Y equals 2 times 3 to the first power is 2 times 3, which is 6. Y equals 2 times 3 to the second power, which gives me 2 times 9, which is 18. Okay, and you'll notice that we have this constant multiplier of 3. Every time we're moving down, we have the 2 in the front, but what keeps getting multiplied by itself is this 3. Y equals 2 times 3 to the third power, which is 50, oh, sorry, going ahead. 2 times 27, which is 54. Interesting. I'm going to have trouble calculating this pretty soon. Let's see, y equals 2 times 3 to the fourth power, which is 2 times 81, which is 162. Wow. Okay, y equals 2 times 3 to the fifth power. Gosh, what is 3 to the fifth power? It's 27 times 9. Here, I'm going to put that into my calculator. Starting to feel like the numbers are scaring me, or I can just put 3 to the fifth power in my calculator and then times 2. So this is 2 times 243. Holy cow. Times 2 is 486. Wow. Okay. So as you can see, these numbers are increasing very rapidly. That's why I was saying it'd be great if your bank account did something like that, right? Let's take a look at what this looks like on the XY graph. Y, X. Well, the X values I put were pretty small, 0 through 5. 1, 2, 3, 4, 5. Okay. The Y values increased very rapidly. 2 was the smallest number here, and all the way up to 486. Wow. So if I were to put 5 hash marks here on the y-axis, each going by 100, let's take a look at what this would look like. Now it feels a little bit silly, right? Because so many of these numbers are below 100. Well, at least the first 4 values are below 100. I'd have to try to break this up into 10 little things to get that, but let's just try to put it on there anyway. So at x equals 0, y equals 2 is pretty darn close to 0. Right there, my dot is probably bigger than the difference in amount there. When x is equal to 1, y equals 6, so I don't know, ever so slightly above the other one on the scale that I'm showing. When y equals 2, x equals 2, excuse me, y equals 18. So that's about here. I'm really struggling again to keep it all on the graph. When x equals 3, all of a sudden we jump up to about here, 54. When x equals 4, okay, now we're past 100. Oh, about right there, I would say. We're above 150. When x equals 5, we jump up to 486, way up here. Okay, I don't know, somewhere like there, just to guess. And what you're seeing in general is something that looks like this. Whoa. And you see this, all of a sudden this, we might start out kind of slow, but we get this rapid increase. Okay. And over here on the other side of the graph, it just heads ever closer to 0, out towards negative infinity that way. And it just keeps getting greater as we go out to infinity that way, very fast. So here's a model of exponential growth. And I had relatively small numbers in here, but as you can see, because we're multiplying by a power, this thing just really goes up. So, okay, there you go. There's a quick example of exponential growth. Stay tuned. In the next video, I'll show some exponential decay. And in the next video, I think instead of starting with the function, we'll start with an example and try to come up with the function. So stay tuned.